Hi guys, welcome back to the shop. Hey, today I'm going to get on the RM250 crankshaft. We're going to at least get started on it. We're going to go over, spec everything out. I'll show you all the information that I've got. It's kind of hard to find some of it. You would think you would find it in a shop manual, but there's very little information. Maybe all you really need is there, but it's not what I'm used to having. A lot of the other manuals, when I say other manuals for other models of a Suzuki shop manual, have clear, concise, complete information as far as runout, clearances, shake, all those other things that they have you check for. And on the RMs, you would think, being a race bike, there would be more information. But maybe I'm just looking at it wrong and they're giving you everything you need. And I'll explain when I get to the point. But anyhow, we're gonna look at this thing. We're gonna show you some of the specs that I have. And then we're going to go over and check it before we take it apart, and then we'll take it apart. I'm not real sure whether I'll get back to assembly today or not. Probably not. So let's get started on it. All right, here's our crankshaft that we're going to deal with. And this one is another one that I bought. I've still got one that I think I can make work. I'll probably have to repair the sealing surface on it, but this one seems to be pretty good shape. I really kind of think this one could be used as is, but you know, I just don't want to put it back together that way. If we can take it apart and check to see if it's like the rod can be used and just put a new bearing in it or whatever, then, you know, we're ahead of the game. But just sticking something in with that's as old as this, and we don't even look at it, you know, that's really not good shop maintenance or practice. So anyhow, let me show you what I've been going through as far as information. And, you know, I just want to say that, you know, normally we have, you know, they tell you to, okay, pull up and down. If you have any movement, then you probably need to rebuild the crank. And I don't feel any movement up and down. But they also tell you, you know, this here movement, side to side, this is what they call a shake, or at least Suzuki does. And they usually give you a tolerance for that, but nothing in this case. Another thing that they usually tell you to do is check your clearance between the thrust washers. Now these thrust washers are a little different because they're like the TS400 that I did not too long ago. They're not the wide ones. These are like this. So I'm thinking I probably really don't need that information as long as my width is right. But anyhow, I'm checking it here before I tear it apart. And, you know, granted, there's probably a little wear there, but I'm really not sure. But anyhow, I'm getting about 23 thousandths when I check right there. And I went back and actually looked at the TS400 that I did for a gentleman. And what was that? Let me see if I can find that real quick. Okay, the only thing I've got here is on my phone. And this showed 6 to 20 thousandths, what they call the connecting rod big end clearance. And that's one thing I just cannot find for the RM. So that's why I wanted to make sure I checked it before I took it apart. And actually I've got a couple of them, so I'm going to be checking. I think I've got 2 that I can check right now, and maybe 3. We'll see. I'll see what I can come up with. Okay, I do. I've got 3 that I can check there. I had another one, but it was just junk. So these are, I think all these are salvageable. They just need repair of the sealing area. So here's one here that I'm not going to use, and I'm coming up with about 23 or 24 right there. Okay, and here's another one. Okay, yeah, 23. And then I've already done the one I'm going to do. So this is the one I'm working on. These are, we're just using them for some comparisons. And you know, this is a way to get some good information actually. So let me get rid of these. I don't think I'll need them again. Okay, this is actually a owner's manual / shop manual for, I actually went to Suzuki. They still have it and they'll print it out for you. It's kind of spendy. I think it's about 70 bucks for this little book, but it gives you pretty much all the information you need. Okay, and here it tells me, basically it's all it gives me is the runout and how to set it up in your V-blocks, which I really don't care for this. I much prefer putting it between centers on the lathe. I just think that's easier to deal with and a better, it gives you a better measurement. As long as your dimples and the end of your shafts are in good order. But that's all I'm getting out of this book is 2/1000 crankshaft deflection, or what I call runout. Okay, so we're probably done with that book. And then I've got this one. And this one, I think, is just a recopy of the original Suzuki shop manual. And here's the same thing. It's given me the deflection. Now let me go to the shop manual, which is right here, service manual. And here it is. So if you compare these two, this is all the same stuff. So this serve, what the heck is this thing? Cycle Serve Publications is basically just a reprint of the original, as this one is. I actually have an original copy. Doesn't have covers on it anymore. I'm not sure where it is right at the moment, but it's just like this one. I saw it here a couple weeks ago and I compared it to this one. So far we've got a lot of run out, and it's the same on all of them, but very little other information. Okay, so I can pretty much put these three away. Just not much there. And then I can go to my climbers. And usually there's not much in these, but there's a little more this time. And we go through, in this book, they're telling me to use these knife edge, and that's V-blocks, and that's what I actually made. But still yet, I prefer the lathe if the dimples are good. So this gives us a little more information over here. And you remember I always measure the crankshaft webs right here? Well, they're giving me the information right here. And on the RM250 A, B, C, and C2, which mine's the C2, it tells me that dimension should be 59.9 to 60.1 millimeters. And that's where I'm saying on these thrust washers, on the ones that have this type, if you get that dimension right, then you don't need to care about the measurement that I'm taking with a feeler gauge there, because this is what you're after. You're after the 59.9 to 60.1. And that is just inconsequential. It makes no difference what that is. That's probably why it's a little wider. But anyway, there's quite a bit of information in here. And to just back that up, I go to my Suzuki service bulletin. And I can go back to my crankshaft dimensions right here. And you can see RL, RM, TM, TS250. 60 millimeter. They're not really, well, they are. They're down here, it gives me a tolerance of plus or minus 0.1 millimeter. So that would be the same as what the Climbers is giving us then. So we're wanting to get as close to 60 as we can. And, that's the same thing. It's showing our dimension right here. And that's how I always measure them. And you would think that this information would be in the shop manual, but it's not. For some reason, Suzuki wanted to include that as a bulletin. And actually, if you look at the Yamaha stuff, it's very similar. They put out a separate kind of a fold out for the Yamahas that do basically the same thing. It's a dealer bulletin or a dealer sheet that they give out that is not in the manuals usually. But that information on the Yamaha is a little more freely found out there. Okay, just a little more information. This is a really bad rod here, but to just show, these thrust washers are the same size as the bearing that goes through this. They're not like a thrust washer that goes out here like on the Yamahas and Kawasaki's and many Suzukis too, actually. But for some reason, I noticed on the TS400 that I did here not too long ago, it was like this. And it seems like these RMs are going to be like this. Okay, and they're also the same size as the bearing, you can see. So it's almost like the rod can, well, it can, it's not almost. It's just, the rod can traverse this whole area here. It can go inside the rod. But what it does do is it gives you a little bit of a, when you squeeze it to the 60 millimeter web width, although this can go in and out, it's, I think your dimension, your side play here, is set when you get that dimension right here. So let's take a look at that. This rod and everything I've got here is a Vintco, and I've kind of undercovered some information there too. We don't know what we're going to need here yet. We may just need a bearing, but the Vintco kit, by the time you find a bearing and a pin for a RM, you've got almost the same price as the Vintco kit. Anyhow, let's go ahead and check our measurement here. I'm set at millimeters. And at the pin, 59 93. So we're right there. And then we'll go over here about 180 and check it again. And I'm getting 59.95. So we're good. So essentially, if we can get that width when we put it back apart or put it back together, we're in good shape. Now, obviously this pin that comes with the Vintco kit is the proper length. It's about 59.79. We'll get that apart. But I've been doing some looking too, and you can get this pin. I picked up 3 of these on eBay for basically 10 bucks a piece. So they're a little bit shorter at 57.94, so about 58 millimeters. But really, it's almost inconsequential. It doesn't really matter. It would work no problem at all. You know, it would just be recessed a little bit in here, and a lot of them are anyway. You know, this one here happens to be flush, but I put a lot of them together that aren't. But anyhow, I think you can use these, and they're the late model. I think they're starting at about $19.99 into the 2000s, and they're readily available. I think you can still get them from Suzuki, but you know, you can find them sometimes cheaper where they're trying to liquidate parts, and that's what I was able to do. So I just went ahead and got them, and you can actually get the bearing also for about $30 right here for the lower end. And I think the bearing from Suzuki is, I don't know, 65. And then the pin is about 62, I think. So we'll go into this a little bit more later on. But for right now, we need to get this set up in the lathe, and we'll check the runout on it. Okay, before we do anything to check our runout, let's check what Suzuki calls the shake. And the shake is just what it looks like. It's this right here. Now when you do this, you want to make sure that it's not sliding back and forth at the bottom, because that's going to give you erroneous reading. All right, let's see what we got here. Okay, I've got it pushed all the way to the left, and I'm going to kind of put my finger right here so that I can't slide it. I just want it to rock. Oops. I need to get back to our 0 there. Okay. So we got about 40 thousandths or so. Let me get this set up the other way here. Zeroed out this way, so that we can actually still not getting it, am I? Okay, about 40, 45. And that's about on par. Usually they're about 30 to 32 to start with, and up to about 140, something like that. So that's really right where they normally set for setting a new one up. So that's almost to new standards if you're looking at, say, a TS or a TC Suzuki or something like that. Now let me go ahead and get set up to do the run out. Okay, got it set up between centers here. And again, when I do this, I turn my taper each time for it setting in here. Otherwise, this chuck would produce about 2 to 3 thousandths erroneous reading. It's just not that accurate. But once you turn it in that chuck, this is perfect for what we're doing. So I'm out here on the bearings or the seal surface here, and on the bearing surface here, I believe. And the seal goes in here, I believe, on this one. But anyway, got them zeroed out. Got about 1 thousandths there. And let me see here. That's a little bit. Okay, I'm trying to get them zeroed this way, so they are now. Okay, so I'm getting just over 1 thousandths here. It's not, we could say 1 thousandths or we could say 1 thousandths and a half. And on this side, I'm seeing about 1/2 thousandths. So we're in real good shape. They really did a good job putting this one together. Hope I can get it that close going back. But we're within 1 thousandths and a half here. So we'll go ahead and get it out of here. Okay guys, I've got it in the plate here, the separation plate, and we're just going to push one side out at a time like we always do. Make sure that you've got clearance underneath the plate and in the back where you're not touching anything with your rod. Let me get you down there and look. Okay, you can see here that we've got clearance on both sides of the crankshaft, so we're not pushing it along the edge as we're pulling it down. And make sure that you've got clearance back here. You're not, this is not touching anything so that it'll bend it. You don't want to bend it. So other than that, we're just going to place our press pin right here, and we'll start the press. Okay, let's see what it does with our new reinforced press. Sure, it's going to pop when it busts it loose, but after that it should be pretty smooth. I'm just checking my rod again, and I'm going to hold on to the bottom of the crankshaft. Okay. There's the other side with the washer and everything. So we'll go ahead and pull the next one. Okay. All we've got here to drop out is the pin now. So let's go ahead and press it. Okay. Looks and feels good. right, here we go. Got our two halves apart. Everything looks good here and in the press hole, pinhole. And these are, the dimples are in good shape. The sealing areas are in good shape. The bearing surfaces are in good shape. This is a good crankshaft here. Now, I looked into this rod, and it is beautiful. Top and bottom. This is a good rod. Nothing wrong with this. You can see that the old bearing was non-caged. I mean, it's caged, but it's loose caged, if you will. And the pin looks good. There's no, I can't feel anything on the pin. And we're going to measure everything up here and just kind of compare it. That's probably more of a hindrance than a help. Okay, let's just take a look at these rods first. And gosh, they look just fine to me. Looks like a good replacement rod. I just want to verify. Okay, the pin fits good there and fits good there. And the lower and the lower. So everything is compatible, it looks like, as far as the rod goes. Now these were the thrust washers removed. I've got 58 thousandths. And 58 thousandths. And you can see, actually you can still see crosshatch from when they precision ground these. So they're not wore excessively. So let's check these new ones. 59.5. 59. So, you know, they might be wore thousandths. Not a big deal. Let's take a look at the weight of the rod. And we'll go in grams here. 202 on the OEM Suzuki rod. And 200 on the Vintco. So we're saving about 2 grams on this one. $8.59. $8.58.5. $7.87. $7.86. The old pin. All these dimensions are in inches, guys. 2.358. 2.354. So 4 thousandths shorter with the new one. So it looks like we're good and compatible with these. We'll make sure these will go in the old one. They will. And certainly go through the new one. So we're looking pretty good. What I saw here, there's really no need to change the rod on this. The bearing and everything is good. We have no wear. I'm going to go ahead and put the new one in because that's what you do when you do something like this. It's, you know, I do have another bearing here, and of course I've got some pins, but I'm going to go ahead and put the new rod and everything in because it is 50 some years old. And what I'll do is I'll go ahead and build up one of the other crankshafts that have bad rods and bad bearings, and we'll use these. Now, the one thing that I've noticed I'm going to let you, you're on your own here to do this, to use it if you want, but I've got an SKF bearing, and it's a KT 24 3020. These are made in Germany, so they're quality bearing. The one thing that is different, I believe, is the count on these rollers. Give me a moment and I'll count them. Okay, I just counted this and it's exactly what I thought. The OEM, in this case right here, is 19 rollers, and this one is 17 rollers. Everything fits good and tight. It's shouldn't be any problem. And if you can find these pins, I believe these are the later model pins, 12211-05D 00-000. And these are about 2 millimeters shorter than the OEM one. This is OEM. Like I say, when you push these in, they're just going to be recessed 1,000 or a millimeter on each end, each side. I wouldn't be afraid of it at all. So at one point, I'll be using this rod, this SKF bearing, and that later model pin in one of my other crankshafts. It fits just as good. Fits just as good. I'm not sure what the idea of the other rollers are. Let me count this one here and make sure. Yeah, this one's 19 also. But it's a cost thing. I bought the SKF bearing for $29.95, and I got the pin for a little over $10, and I don't see that it's going to be an issue at all. I've put a lot of crankshafts together with a millimeter shorter on each end. There's plenty in there to hold it. If you were out and out racing, might be different, I don't know, but I've never had an issue with one when they're a little bit short like that. Just a little bit. By the time you spread that difference out on both sides, it's hardly even negligible. So there's just some good information. Sometimes when you don't have any little bit that you can get, you're happy to get. And that's kind of what I'm trying to purvey here, is that I'm sure there's some people out there that know a lot more about this than me, but I'm going to give you the information that I know. And like I said, the width of the crankshaft halves assembled, that should be in the service manual, but it's not. Not in this case. You have to have a copy of the bulletins in order to have that. And that's why I always stress, before you tear them apart, make sure you measure them, because at least you can get them back to where they were. I think the one thing I forgot to do was measure the diameter, but they are a, well, that thing is shaking. It's a 24 millimeter pin. Same on the Vintco, $23.99, $23.99, $23.99. So these are very precision ground. And this is the shorter one, and it's the same. I believe it's $19.99 to about 2012 or something like that. These are a lot of them out there. They're quite expensive if you get them from the dealer, but if you can find them parts, you know, where they're trying to liquidate stuff, you can pick up a good deal on those. That's why I bought 3 of them, because I know I can use them, and I can use these SKF bearings. The bearings are pretty expensive also. I think they're around, you know, close to the same, 60 bucks or something like that. And you can get that one for 30, so half the price. Okay guys, there you have it. This is the kind of the review, the measuring, and the tear down of the 78.5 RM250. And the next video, we'll go ahead and we'll build it up, get it back in shape, get the run out right, get everything that we need to do to it to get it back into the engine. And you know, that takes quite a bit more time to kind of massage everything when you're done, unless you're just lucky. But I think we're just going to use the new one, but there's nothing wrong with the rod out of the old one. I'm going to reuse that in one of the other ones that I have to work on. And that way at least I'll have a spare laying around just in case I need it. So thanks for going along for the ride. See you next video.